and a brief idea about the overall course plan. That's what we are going to talk about today. So let me first open the topic list. All right. So yeah, it's a big one. It contains a lot of stuffs. We have 90 hours of training, and it would take 2.5 months to complete. What that means is, if you are joining this batch, we are going to complete the training by this is April 23rd. So it's going to be 2.5 months from now. July first week is what we will finish the training. And yeah, before we begin, there would be few things that you need to know. Some prerequisites. Actually, to start with this training, there are certain things that you need to know first. You should be clear with what is a software and what is a web application, and how does a company manages a software. What are the different teams involved who work on the software? Please keep yourself on mute. Albina, please mute yourself. Yeah, thank you. Right. So you should know what are the different teams in a company who work on a software. And I know most of you are from an IT background, but it's still, I just want to make it sure that you have these concepts clear. You should be comfortable working on Linux, some Linux administration stuff. How do you install or configure a software in Linux environment? How do you run a website on a Linux environment, right? How you can register your own website. There are few things, and how software applications communicate to a database. Then there's some networking basics, right? How the machines communicate inside a local network, and what is mean by a local network, how the machines communicate there, what are the different components of a local network, how the internet works, right? What is an IP address, private IP, public IP, few concept. So our first 2 weeks would be all about some prerequisites. Starting from the Linux basics, first couple of days we will spend on the basics of Linux. Those who are new to Linux, if you are from a development or a different background, it's very important that you should have a proper knowledge about Linux, right? What is Linux as an operating system? What are the different actions that you want to do? How do you copy a file? How do you install a software? How do you create a user? There are certain basic things that you need to know about Linux, which we will be covering in the first couple of days. After that, only we will move on to the actual prerequisites training, the Linux administration and networking training. Certain things that you need to know before you begin our course. So our first 2 weeks will look that way, only the prerequisites. And the class timing will be 6:30 a.m. IST, the same time as we started today. It's 6:30 a.m. IST, the same time as we started today. And we are beginning the class from tomorrow. And after we finish the prerequisites training, that means the Linux basics, Linux administration and networking, our class timing will change to 7:30. That's the plan. And from then it's going to be 1.5 hours per day. Till then it's going to be 1 hour per day. And the classes are Monday to Saturday for first 2 weeks. After that, it is going to be from Monday to Friday. That's the plan. So ever since after 2 weeks, the classes would be only between Monday to Friday, 1.5 hours per day. All right. Then we have scripting classes also, which we will cover in a weekend. Make a note. Generally, the classes are on weekdays, except the scripting classes, which we will be conducting in a weekend. And I will let you know the dates at least 1 week in advance. So it's not going to be a concern. Before we finish the training, we will be finishing shell scripting and Python programming as well. and it's going to be in a weekend. I will let you know when it's going to be, at least 1 week before. Okay. And after we are done with the prerequisites training, except scripting as I said, we will conduct later. After we're done with the prerequisites, we will move on to our DevOps and AWS training. DevOps is split into three courses actually. We have continuous integration and continuous delivery training. We have config management training, and then we have the containerization orchestration training. Each of this training will take 2 to 2.5 weeks to complete, and all this training come along with a real-time based project. I would be at the end of each training, I would be sharing a document with you which would contain a lot of project scenarios. There are certain things that you need to do after we finish the training, right? You need to know what are the problems that the companies are facing and what is the purpose of this course, right? This the real picture you would get from the projects. So you will have one project starting after each of this training every 2 weeks. What that means is every 2 weeks we start the new courses, and every 2 weeks you would have a project starting. So make sure that you are doing the project along with the training. And then we have AWS training. Again, it will take nearly 2.5 weeks to complete, which is also a project based training. And the AWS project is comparatively easy when compared to DevOps, because we do the project along with the training when we learn AWS. In case of DevOps, you have to start the project only after we finished the individual topics. So after we finished 2 weeks of CI/CD training, at that point only you can start with the project. And that's how for DevOps. But AWS we will do along with the training. In total we have four projects, one into AWS and three into DevOps. Very very important projects. It contains a lot of real-time scenarios, right? The use cases of what you learned in the training is what you would implement in the project. And along with the training, I'll be recording everyday classes. You would get access to the recorded videos. Nearly 90 hours. As I said, our training would take 90 hours or 2.5 months to complete. Everyday classes are recorded, and the recorded video would be kept in a Google Drive. You will get access to that Google Drive. Apart from that, you will also get access to one training portal, a training portal where you can log in, and then you can manage your entire course curriculum. You can watch the recorded videos, you can see the course materials, you can download them. Then you can find your assignments for each sessions. For each tools that we are learning, there would be assignments. You can see those assignments, you can work on those assignment yourself, and after that, after you finish your assignment, you can submit the assignment from the portal itself. Your grades, after I put the grades, you can see your grades also in the portal. You can chat with me or other students if you have any doubts, questions. There's an option to chat with me or post a question to everyone. So there are many options that you would get from that portal, and you will get access to that portal even after the training. Total 9 months of access you are going to get for that portal. What that means is, in case if you have something pending after the training, you can continue to contact me, get my support, and finish the projects. If you haven't finished the project along with the training, you can continue to work on the project, right? All these options are available even after the training. All right. So as I said, after we finish the prerequisites, we will move on to our actual topics. As I told you, within DevOps we have three courses. Each page indicate one course. One is the first one is CI/CD, or you can also call it build and release automation. And these are different tools that we are covering in this training: Git, GitHub, and Maven, Jenkins. We are also covering Nexus, right, which is a bind repository. And this course is all about the software change management. A company who has a software product, who want to manage that software product, who want to make some change in the software product, how do they manage such kind of changes that they want to make on the software product. For any company, they want to do it. That's how the software companies work today. Whenever they want to make some modification to their software product, for example, the company like Amazon.com, they are a retailer and they want to keep on adding more and more features to their software product. They want to add a prime customer option so that they can retain many customers as their favorite website, or they can give a new option to make payment using the mobile banking, right? Like that, there are lots of new feature that the customer need from Amazon, and it is their responsibility that they provide all these options to the customers. So what that means is they have a software product that their customers are using, and they want to keep on making modification to that software product, make some change to the product so that it is added up with more and more features. And when the company may add more features to a software product which is running absolutely fine, you can actually expect some new issues getting introduced to the system, right? When a company have to work on the software and try to add a new feature to the software by accident or by mistake, a lot of issues can get introduced to the system. For example, a developer who was working on adding the mobile banking into the Amazon.com website, right? By mistake, he broke something else. He broke the credit card system. Now the customers are not able to make payment using credit card. So these kind of issues can get introduced when you add new feature to your software product. So how do you make sure that such things are managed in the right way? Or you cannot assume that the issues will never happen. The issues will happen, but whenever the problem happens, you should make sure that the problems are detected at the very early stages of development so that the fix can be done very quickly, right? Without your product changes going to customer, you should be able to detect the problem, and you should be able to detect the problem in the earliest as possible so that you can fix it, and developer would not get too much confusions. If you think about this, developer made some code change, he made added some new payment method on their retail website, and he's waiting for somebody else to give him a feedback on his change. But it would take maybe 1 or 2 weeks to get a feedback from a testing team saying that something is not working, right? A testing team after 2 weeks complained that the credit card system is not working. So at this point of time, it's already 2 weeks past. This developer have no idea where this problem came from, because he know that he worked on a new payment method. There is absolutely no chance that the credit card system could get broken up, but it happened. And what I'm trying to say is there are a lot of confusions if developer get the late feedback from different teams. So you should introduce a new culture within the team, right? That's what you do as a DevOps engineer. A new culture within the team where you do a lot of automations and you avoid too much human interactions when a software change need to be managed. Of course, you need the development team. It's the development team who will make change to the code, and right, the softwares are nothing but it's developed by writing plain text code by the development team, right? It can be Java code, it can be PHP code, it can be any programming language where the software was based on. So developer do make the code change, and that is a work that they will continue to do uh, as long as the software stay in the market, right? Till end of the software lifecycle, the developer will continue to make modification to the software. What I'm trying to say is, once software modifications are being made, you don't really need a lot of human interaction to verify the change done by the developer. Rather, the change should get verified itself through a series of automated process. For example, a developer writes some Java code. He's adding a new payment method on the retail website that his company owns. He makes some code modification. He added some new function for the new payment system. He completed his work. He did the code change. And think about this. As soon as he finished his work, an automated process had started, which took the code modified by the developer, compiled it to a machine understandable form. Then this code probably depends on a lot of third party dependencies, and assume all these dependencies are downloaded automatically from internet or from somewhere, and the code get converted into some executable form. This executable files, anyone can install it on any machine. Then that machine can serve the payment system, right? The new payment system or whatever the developer have been working on. And but remember, this executable file is not ready to go to your customers. This executable files is only for your internal reference. You want to first make sure that it's working fine before you move on or before you deliver that changes to your customers. So for that, every company will have a lot of testing machines in different environment, right? Because a lot of advanced testing need to be done on the changed code, so that you know that the code is going to work for your customers without breaking anything. So think about this executable file which need to be tested. First you run it on a test machine, and through in a automated way, of course. So as soon as the developer make a modification, the code is taken, code is compiled, then code is tested for the new functionality added by the developer in a automated way. Developer added some new function. It will quickly verify the new functions by running the code. And if it is looking good, then the next thing what it does is it will download all the dependencies that the code need, then put them together as a executable file. Then this executable file will be run on a machine for the testing purpose. Make sure that all the tests are run, and this new executable file is able to make the payment using the mobile banking, or I mean whatever new function that your developer have added. And then there are many other testing also that you want to do. You take the same executable file. If it is working fine, you take the same executable file, run it on other sets of machines where you run more advanced testing, and this process will continue. And each time these executable files are being tested, a report gets generated based on this testing. Assume the report is also getting verified in an automated way. The testing is also running in an automated way. So assume you achieved a complete automated pipeline, so that whenever developer makes a modification to your code, after the developer made the modification and uploaded his work, or in other words uploaded his code modification into a storage place, a automated process would begin, which would in fact take the code from the developer, walk the code through a series of stages until the code get verified completely, right? That would include compiling the code to a machine understandable form, running some basic testing to make sure that the new functions are working fine, converting the file into some the code into some executable form so that you can easily install it on a machine. Then you will run it on a machine, then run some sample testing by using some automated tool. Then a report gets generated based on that. Assume the report is also getting verified in an automated way. In case if there is an error, an email is sent back to the developer asking him to take a look at the problem. And if it is looking good, then again it will be deployed into other environments machines where more advanced testing would be performed in an automated way, and a report gets generated based on that. Again report get verified and then send out an email to the development team, and if any of the stages fails, developer would get an email. So what, in other words, I'm trying to say is, your development team who is working on the software, they will make the code change and they will relax, right? They will wait for the feedback coming, or they can move on to the different work. If there was any problem, they will definitely get an email from this automated system, which you designed as a DevOps engineer. Yes, you are the one who will take care of these kind of automations, and this automated system that you defined will give a feedback to your development team whenever there is something wrong. or whenever it believes that the code is not at all ready to go to the customer, it need to be modified or it need to be worked on further. In any of such cases, this automated system will detect that and it would send out an email to the respective developer. So for the developer, they just work on whatever change requests that are coming to them. So maybe the change request is nothing. What is mean by change? By the time change, I'm talking about any change that you want to make on your software. So probably a new feature that you want to add to the software, or a problem that you want to fix on your software, right? That's what I mean by change, right? So a lot of requests would come to the development team or different teams within your company to make change to your software product. For example, the marketing team who believe that a new payment system need to be added to the website, so that there are many customers who are using that payment method can purchase items from our website, right? Those kind of requests can come from the marketing team, or the request can come directly from the customers or from the testing team who work on some testing. They detected that there is some problem which need to be fixed, so the testing team would ask the development team to fix this problem. So a lot of change requests would come to the development team. So whatever change requests that are coming to them, they work on it. In case if there was a problem in their work by accident, or by some integration problems, right? Any issues that occurred after the developer modified a code, he will come to know, he will get an email. If you don't get an email, what that means is everything is looking good. So developer does not really have any dependency on anybody else. He don't need to wait for a testing team to do the testing of the change that he made. It's not required. Tests are run in a automated pipeline, or the development team need more machines where they want to run the testing. Again, that's also not required. This automated pipeline, it would create the machines whenever it need them without any human interactions. So this is the new way of working on a software and being adapted, right? Mostly adapted by most of the IT companies today. It's a big change in the culture, and this would actually enable the delivery of the software very fast, right? Otherwise, think about this: a testing team who work on doing the testing, they need a good amount of time to do all the testing. A lot of engineers need to be involved. They want to do a lot of manual testing, they want to run a lot of automated testing. This they spend a lot of time on doing the testing, and they won't be able to give the feedback to the development team in time because they have a lot of work to do. They give the feedback maybe 1 week late. Remember, it's your software delivery that is getting late. You are not able to deliver your software to your customer at least for a week because it's still pending. Testing is still pending by the testing team. Or sometimes development team or the testing team may not have proper environment where they want to run the testing. They don't have proper machines, they don't have enough machines where they want to run the testing. They need to wait for the operations team, which is a different team in a company who manages the software, and they have to create the machines for the testing or development team to run the testing. And again, it's a time consuming process, it can take a lot of time. And operation teams are the most busy team in a company, right? They have a lot of things coming from different departments. So whenever they get a request from the other team asking them to create the environment, probably they are already busy, and the requester need to wait for a long time to get their request. So developers or testing team have to wait for a long time from the operations team to get the proper environment where they want to run the testing because they don't have proper environment till now. So these kind of issues are completely avoided if you have a automated system, and this is a new culture which is being adopted by all the companies across the world today. So what our course plan is, we will take some sample Java applications and we will learn all these tools along with that, with use cases of a Java application, for example, a cab application or a retail websites. A sample, right? You don't need to worry about the code or software. You are not the one who will make the code changes. That's not your responsibility. But it's important that you need to know the architecture of the applications and certain stuffs. That's what we will be focusing on along with the training. And these are the tools we are covering. Nexus also we are covering, but not in detail. But Nexus, there are many other things also which will come on the way. Apache, Tomcat, Nexus, then something comes from the software application side, something comes from the DevOps tool side, right? We will be these are the main tools that we are focusing on in this build and release training, automation training. And then after we finish this, we'll move on to the config management training. This is all about taking care of your infrastructure and configurations. For example, I know that, yeah, I'm using a lot of technical terms. Don't worry about it. Just try to understand it on a very high level basis. All right. Please don't get confused. Those who are new, don't get confused, and just try to focus on a very high level time. Right. The config management is all about, if you have a software application stack which has a lots of configurations. The configurations, I'm not talking about the code wrote by the developers. I'm talking about a lot of information the softwares need. For example, a software application developed by a Java developer, it want to know where it need to save its cache. It has a lot of cache which it want to temporarily save in a place. Where should it save it? How much time should it save it? Or after how much time it should be cleared? Or it want to communicate to a database to get some data that the software need. For example, the Flipkart company or the Amazon company, whenever a customer try to log into their website, this software application which try to log the customer into your website, it want to get the details of the customer from a database. Make sure that the user entered the correct mail ID and password that he will fetch from a database, and make sure that it is matching with the credentials which your customer have entered. If it is correct, so the software application want to know which database it want to connect to get this information. So what I'm trying to say is there are a lot of information your different software application need. So how much things would, a huge amount of information. So this is generally called configurations. A lot of configurations that different software application need to know. And based on that, they communicate each other. Based on that, they know, right? They know many important things. So if a human have to configure all these things, think about this. You have a total some 100 small software component. Think about any retailer. There would be one component for shopping cart, another component for prime customize, another component for doing some data analytics, another software component for the GUI. Right? There are different software components that a full application stack will have, and each of the software component need a lot of information. A human have to tell all these things. It's not going to work out anymore because the software is already so complex. You don't want to make any more human errors and make it more and more complex. What you should really do is you should have a proper method to manage all these configurations. For example, assume you want to run the software on hundreds of machines. This is what every company will do. Every company will maintain an amount of machines where they will run their software. Maybe hundreds. Companies such as Amazon.com will have millions of machines, believe me. And these machines would run their software that are developed by their developers. One machine would run shopping cart software. Not one machine, maybe 100 machines would run shopping cart software because they get a lot of requests from the customers. One machine may not be sufficient, and other machines would be running different software components such as prime customer component, data analytics component, GUI component, database component, the caching server component. Like that, there will be a lot of different software component, and they do communicate each other. People who browse for Amazon.com, from their browser it will connect to this machine, get the web page from that machine. Then the user try to log in, then this component will connect to the database, make sure that the user have entered the correct mail ID and password. User got logged in. Then he try to add some item to the shopping cart. Then what happens is this software component running the shopping cart will take care of adding the items to the shopping cart. So what I'm trying to say is every company will have a lot of machines which they maintain in order to serve their software to their customer, and they do communicate each other. They want to communicate each other. So this machine need to know what is the database machines it want to connect to, or this machine need to know what is the shopping cart component machines it want to connect to, and there are many other information also all these machines need to know. So a human cannot remember all these. Of course, if you have 100 machines, you cannot even remember the name of the machine, believe me. So the name of the machines, IP address of the machines, what software should be installed in each of these machines, what are the dependencies of that software, what are the other software component this software need to connect to. There are many information, or I would call them in general the configurations. Each and every machine in a company's infrastructure will have a configuration, a set of configurations. And this is not something you can remember and manage. What you do is you document it in one tool, a config management tool. You tell this config management tool, these are my configurations, these are the number of machines that I need, and each of this machine, these are the different software component to be set up on the machines, and the config management tool will take care of your machines rather than humans managing it. You will never log into any of your machines, work on those machines. Your config management tool will connect to those machines, configure those machines. For example, as per the configuration that you wrote in the config management tool, some service should be running on this machine. Then the config management tool will connect to this machine, make sure that that service is running in a completely automated way. A software should be installed as per the documentation that you wrote in this config management tool. If it is not written here, it will make sure that it is not installed in here. It will make sure that software get installed in this machine. So how does your configuration look like? The config management tool will make sure that the same configurations are applied on each and every machine in your infrastructure. So that's what Ansible. We are going to learn Ansible in detail. That's what Ansible can do. It can take care of the config management. Again, it's a 2 weeks training. We are also covering Nagios, which is a monitoring tool. It won't take much time. It would be Ansible that we will be focusing on in our training. Chef and Puppet we are not covering, make a note. I just put it here so that you know what are the tools available. These are other Chef, Puppet, and Ansible all are similar tools, and Ansible being the most advanced one, the most new tool, yeah, which has a lot of added advantages compared to Chef and Puppet. That's why we will be focusing on Ansible. Then at the end, I would give you a brief introduction about what is Chef and what is Puppet, what is the difference between Ansible. I'll just have a brief introduction about them. And if anybody need to learn Chef, I have the complete recorded video of Chef, the classes that I had taken before. I have the recorded video. If you want to learn, I can share that with you. And after, at the end of this training, you will get one project. The project would be more like a scenario-based project. Along with the training, we will take some sample project and do it. But when it comes to the final project at the end of the course, you have to. I mean, For each course, there's a project, right? At the end of config management course, your project would look like, we'll talk about one software application stack, which contains different software components and different configurations. So you have to take care of the configurations of that given uh, application stack. That's the project that you will do. And then we move on to containers and orchestration. It's again a 2 week training where we focus mostly on Kubernetes. Docker also we are covering. I mean, Docker is the actual runtime. Kubernetes is more like a orchestrator, which can almost do everything on your software application. It can it can pack your entire software application along with everything that the software application need in small containers, and then it can decide where this container should run, how it should serve software to your customer, and if there is a huge traffic coming to your website or coming to your software application, how do you add more machines that can handle the traffic, right? How do you make sure that the data that you save for your applications are safe and secure and it has proper backup? There are many things that you want to make sure. How do you make sure that your customers are never affected whenever there's a problem in one of the machines? So Kubernetes is something, it can do almost everything, and it can do everything in a very smooth way. It does not involve humans whenever you want to do some deployment means the process of bringing the changes done by the developer into your customers. You, whatever code change that your developer have done, or whatever new feature that the developer have added to the software, you make it available to your customer. That's what I mean by deployment. Or you make it available to customers, or you make it available to the internal testing team or whoever it is. It's done through a process called deployment, which generally need a lot of human intervention. Kubernetes avoids that. Many things it can do, I'm not talking about that in much detail, but believe me, this is the most important training in our course, most important course in our training. As per today's market, every company, almost every IT companies, are either started with Docker and Kubernetes or planning to move their infrastructure into Docker and Kubernetes. Very, very important. It's a 2 week training. At the end of this training, there will be one project also. And then we have the cloud computing training. AWS is what we are focusing on. We will it's again 2.5 weeks it would take. These are different services: EC2, elastic load balances, auto scaling, VPC, route 53 S3. So you will learn more about the infrastructure when we learn cloud computing, about the machines or about the different components of your infrastructure. A company, as I told you, a company need to maintain a infrastructure, a set of machines running different software components. So how do you maintain, or where do you get those infrastructure component? You get them from a cloud computing provider. So that's what this training is all about. Comparatively an easier training, and we do the project along with the training. It's a so there are total four sub courses within our single training. One is AWS, and three comes from DevOps. And then we have these prerequisites. That's what we are going to focus in the first 2 weeks. Then we have a scripting classes, which we will conduct in a weekend. And as I told you, I will inform you when the scripting classes would be, at least 1 week before, so that you can plan accordingly on the weekends. Then that's it. What I want you to do is, there's a website called trainingdoor.info. Earlier, I talked about a training portal you will get access to, right? This is that website, www.trainingdoor.info. I'm pasting that in the chat. So what I want you to do is, I want you to enroll yourself to this batch. The batch name is April 24, 2019. So you go to this website, trainingdoor.info, click on DevOps and AWS complete training. Once you clicked, you would be able to see your batch. The batch name is April 24, 2019 DevOps. click on that batch, April 24, 2019 DevOps. You would be taken, of course, you need an account in this website. Either you can register a new account by clicking this button, or if you have a existing Gmail ID, you don't need to create a new account yourself. You can just log in to this website using your existing Gmail ID. You need to click on this button. Then you need to provide your Gmail ID and Gmail password to log in. In either case, you would get an email asking you to confirm your mail ID. You should complete that verification. After that, you can log in. Then you can select the batch April 24. Then you will see a button called Enroll Me button. If you click on this button for the batch April 24, then you are enrolling yourself. But remember, you won't be getting access until your building contact confirmed it. But you can send me the enrollment request by clicking this button, enroll me, because if I have to send you any messages or anything, any communications, you would receive the message only if you did finish these steps. So it's important that you can, whether you get access or not, go ahead and enroll yourself by clicking this enroll me button, so that I can, whatever message that I want to send to you, it would reach to you. You won't miss out any messages. So do that now. It's very important. And once you this is the place where you can manage everything, right? You can chat with me, you can chat with other students, you can post your questions, you can see the assignments, submit the assignments, see your grades, download the course materials, watch the recorded videos. Everything can be done after you logged into this particular portal. So please go ahead and enroll yourself to this portal. You can do it now. So Sudhir, good morning, and somebody else, Jay, hi. So some of
Hi,
them
hi.
not speak to. Hi.
Yeah, hi,
Good
Sudhir.
morning.
Hi, Basil, right?
Yeah, it's Basil.
Ah,
So I hope you follow. Right? Yeah. So just create your account. Ashok, good morning. So do create your account here on the training.info website. Then tomorrow we will start the class. Same time, same link, same meeting link. At the same time, we will have the class tomorrow. Any questions? Anyone?